Could you able to see the screen now?
Yes, sir.
Yes, sir.
Yes. We're going to talk about the acid hydrolysis. Basically, two types of mechanisms are there. One is dissociative mechanism and other one is associative mechanism. Dissociative mechanism follows via the intermediate formation which is 5 coordinated complex. And SN2 mechanism follows via intermediate formation which is 7 coordinated. Here there is a dissociation, means removal of electron. Here there is an entry of the new ligand, rather than electron, ligand. So increase in coordination number, decrease in coordination number, that's the basic difference. And each, this is a rate determining step for SN1, it is also the rate determining step for the SN2. Here rate depends on only one, therefore it is a uniorder or unimolecular. Here rate depends upon the two, therefore it is a bimolecular or bi-order reaction. Likewise, the basic fundas of the mechanism we have studied. Now it is a time to clearly understand what that acid hydrolysis mechanism actually is. If you remember, I had given you the example of cobaltamine complex, CONH3. In spite of 6, I am considering 5 because I want to replace this halide ion as one of the ligand out of the 6 by water molecule. The charge on this complex is 2 plus because these cobalt 3 ion complexes are. In that, if we add water or that water as a ligand from solvent can replace the halide ion and the resultant product will be CONH3 in spite of Cl. Now H2O will be there because Cl minus is replaced by H2O and Cl minus I am representing that it came out. So it is a simple substitution reaction in which chloride ion or chloride ligand is replaced by water ligand. This ligand carries -1 charge. Here water carries no charge, due to which resultant complex also with difference in charges. Here cobalt plus 3 carries, of course, plus 3 charge. Ammonia carries no charge. So summation is plus 2. Therefore, we have represented dipositive charge on this complex ion. But if we have to represent this product, cobalt carries plus 3 charge. As usual, ammonia carries no charge, whatever number of ammonia molecules there may be, and water also carries no charge. So what should be the total charge on that complex? Yes, what should be the charge here now?
Plus 3.
Right, plus 3 or 3 plus. So it is a reaction, and this reaction is called as acid hydrolysis reaction. People were thinking two ways are there to get the product. First way, that this complex, cobalt amino complex, of course chloro is there, will say goodbye to this ligand Cl minus. Means we'll remove Cl minus first and then we'll allow the entry of H2O. It is a one method, one way. Means which mechanism it is? It is SN1 mechanism where removal or dissociation will be dominating. Other possible mechanism, this H2O will enter first, will become friend with cobalt plus 3. So now there will be this 5 ammonia molecule, 1 chloride ion and this 1 water. So total 7 will be the ligands around cobalt plus 3. So coordination number will be 7. It's an association mechanism and that we say as SN2 mechanism. Water will be associated first and then chloride will be removed. These two ways are there. People were thinking since this complex is positively charged, complex ion is positively charged, ligand water as such has no charge, but water behaves like dipole. Oxygen center is there which carries partial negative charge and whichever the hydrogen ends are there, those carries a partial positive charge. So that negative end will approach towards whom? This positive ion, positive complex ion. So first water molecule is crowding, water molecule is surrounding, water molecule is attacking, water molecule is inserting, water molecule is added there. It was a prima facie expectation considering charges. If that would have been true, what would have been true? In this complex CO and H3 5Cl, which carries +2 charge, if that water would have been added first, we would have obtained which complex? CO NH3 5Cl H2O. So Cl is a one ligand, H2O is other ligand, ammonia is other ligand, but such 5 ligands are there. So will you help me to find out total number of ligands in this complex? Yes, how many ligands are there in this complex?
7.
Yes, 5 plus 1 plus 1. Total 7 ligands are there. The 7 coordinated intermediate was expected, and it is a slow step out of the two possible steps, and I told already by various examples how slowest step determines the rate of the reaction. So this association of water molecule in this coordination sphere, this is a rate determining step, and this rate determining step is with two reactants. Rate is directly proportional to the species on which it affects, actually general point of view, the reactants. So which two reactants? One reactant is this complex CONH3 5Cl2 plus, and other reactant is H2O. Since rate of the reaction depends on these two chemicals, it is bimolecular reaction, or mechanism is SN2. It was thought of the people. What was the thought? Acid hydrolysis might be undergoing the course or the path of SN2 mechanism. Why were they thinking? Because they found complex ion carries positive charge. So whatever the ligand water is there is going to add, that ligand will be attracted first, because they noted crowding there. Just is a simple process of hydration or the solvation. But at that time they realized that water is crowding, water is going, so water might be entering first. If it is true, then rate of the reaction should depend upon the two species, so SN2 should have been the mechanism. But when a study proceed, people come to know actual mechanism is SN1 only. Means what happens there? Reactant, it is our cobalt amine chloro complex, CONH3 5Cl, charge on that is 2 plus. It undergoes dissociation. It is a 6 coordinated complex, and that 6 coordinated complex will form 5 coordinated intermediate. Of course, plus Cl minus will be there. But this intermediate is 5 coordinated. It is our step number 1. First step is a dissociation step. Second step, whatever the resultant complex is there in the first step, that is 5 coordinated intermediate, it is unstable. Intermediates activates our reaction or helps us to complete the reaction. Short-lived chemical species is a 5 coordinated intermediate. In that, the ligand which will substitute other ligand, that is the water, will enter, and the complex, new complex will be CONH3H2O. Of course, octahedral, charge will be 3 plus. This is 6 coordinated product. It is our 5 coordinated intermediate. It was the second possible mechanism. If this mechanism would have been true, then what should be the rate law? Rate of the reaction should directly proportional to the reactants which are in rate determining state. Here there is only one reactant, that is complex CONH3 5Cl2 plus. This rate law was found to be valid experimentally. If that rate of the reaction depends on only one species, only one reactant, that's an octahedral complex, then mechanism should be SN1. Likewise, people were thinking. At the beginning, they started with SN2 mechanism. but later on they concluded it is what SN1 mechanism. So what actually mechanism is the molecular mechanism I represented here? Let me represent structural mechanism. Structural mechanism means I would represent the coordination number in terms of the geometry. First, octahedral complex, cobalt plus 3, a central metal ion, and which is with total 6 ligands. Out of that, one of the ligand is chloro, and remaining ligands are amine or ammonia or NH3. NH3 molecules are neutral and chloride carries -1 charge. Cobalt carries +3 charge. So this resultant complex is with charge, that is +2 or 2 plus. It is our reactant. And this reactant will undergo dissociation to produce 5 coordinated intermediate. 5 coordinated intermediate means it is a trigonal bipyramidal geometry. A metal cobalt at center and 5 ammonia molecules will surround central cobalt plus 3 metal ion. Of course, this 5 coordinate complex is not so stable, but it obtains there, which has +3 charge. Why? Because ammonia carries no charge and cobalt is with the +3 oxidation state. So what happens in this reaction? Dissociation of whom? One of the ligand. Which ligand? Chloroligand or the chloride. So it is our first step of the mechanism. This I am writing structurally. Second step, whatever this 5 coordinated intermediate is there, let me represent it again. A cobalt metal is at center and whatever the 5 bonds possible are from ammonia molecules. And total charge carried by this intermediate is +3. Now in that the other ligand which we want to substitute will be added, that's H2O, and we will result a new octahedral complex where one end will be by water or water will be the one of the ligand and remaining 5 ammonia molecules are as usual. Charge carried by this complex will be +3 because cobalt carries +3 charge and ligands which are surrounding nobody carries any charge. It is a structural mechanism. So in examination, if you have to answer the descriptive question, then these both kinds of mechanism, molecular and the structural mechanism, especially for the base hydrolysis reaction, the structural mechanism will come for the help. But nonetheless, here also it is important, a simple thing that I am informing to you, but is very important for understanding in future. So students, I want to know, are you understanding what I am saying?
Yes, sir.
Yes, sir.
Yes. So in conclusion, acid hydrolysis follows which mechanism? I want answer from you. Acid hydrolysis follows which mechanism? Just now I have shown you mechanism. Structural and molecular reactions were represented. The mechanism where 5 coordinated intermediate is obtained. What is the name of that mechanism? What is the name of the mechanism?
SN1 mechanism.
Right, SN1 mechanism, dissociative mechanism, it is the actual mechanism for acid hydrolysis. Being a science student, you may be with the question, on what ground are we saying that this mechanism is acid hydrolysis? So now students, I inform you the grounds by which we are concluding that mechanism is SN1. The first ground is charge on the complex. Effect of charge on complex. So two complexes were studied with different quantities of chloride. Which complex so far we know it is a cobalt, amine and monochlorido complex. This complex. And other complex people have studied where in spite of 5 ammonia, only 4 ammonia and in spite of 1 chloride, 2 chlorides are there. I repeat, people have studied monochloro dipositive ion is a one complex, as well as they compared the study with dichloro monopositive ion. Students, are you understanding what I am saying?
Yes, sir.
Yes. Monochloro dipositive and dichloro monopositive complex ion. Two ways were there, people thinking, one is SN1 and other is SN2. SN1 means dissociative, SN2 means associative. What is the actual result that I informed to you? It is found that the complex number 1 is slower 100 times Then complex number 2. This is a complex number 2. It is our practical observation. When people have studied the rates of the reactions, then they found complex number 1 undergoes acid hydrolysis 100 times slower than complex number 2. It is the only the one observation. On the basis of this observation, we can conclude what can be the mechanism. Will anybody infer what can be the mechanism if complex 1 is 100 times slower than the 2? What do you think? Could you able to guess on the basis of the structure, on the basis of the charges? Result I told to you. Complex 1 is slower. If it is slower, then it is very sure for us. This is the only mechanism. So which mechanism can you predict?
SN1.
Why? SN1 that already I told to you. It's true. Absolutely answer is correct. But I want that you should work mentally. Means with understanding. On what ground are you saying that SN1 is a favorable mechanism? How this observation
Slow.
supports? Yes. Will anyone answer? Are you understanding my question? No, waiting for replies. If no, I'll repeat.
Yes, sir. Understood.
Then you think on that. So don't expect ready-made answer. Complex one, how it is? It has only one chloride. How it is? It has two positive charges. Complex 2. How it is? Two chloride ions as a ligand. And how much charge it carries? Plus 1. Actually, go in that mechanism. Associative mechanism means ligand will be added, will enter in the complex. And dissociative means you have to remove the ligand from that complex as a rate determining step. Dissociative step, where efforts will be less or where will efforts more, that you have to find. That is a proper learning. Means you are using your learnings and you are applying. You know already charges. You know how ligands are adding or removing. Or to apply concept.
In first compound, only one chlorine is there, so it will be hard to remove than two.
Okay, only one chloride is there. It will be hard to remove the N2. Good logic. Good logic. Okay, other good thing. Okay, I appreciate. Not a very perfect it is, but okay, I understand. Likewise, you have to think. Metline thinks in terms of the number of ligands. In first complex, so 6 ligands are there. Second complex, also 6 ligands are there. So in first complex, so chloride is to remove. Second complex, also chloride is to remove. Two chlorides are there nonetheless, no problem because sufficient space is there in octahedral. So whatever the first logical argument that I am finding, good argument, but not so perfect because 6 coordinate complex. What is the complex number 1? Complex number 2 also is 6 coordinated. Any other answer? Hint I give it to you. We are removing chloride. We are removing
Charge
chloride
of
ion.
the complex first is more than second.
So what happens? It is true, but what happens because of that? If charge is more, then what will happen?
So ligands are strongly held by the metal ion.
So we're comparing here. Metline will hold both where, no? Why ligands are hold strongly? If you are saying, actually comparing, we are comparing complex number 1 with complex number 2. Just I help you now. There are two complexes. One complex carries plus 2 charge, complex ion you can say. And other complex, reactant complex, carries plus 1 charge. Suppose if reaction would have been SN1, dissociative mechanism. Answer for my question. What shall we remove? Which ligand will remove? Which ligand will remove?
Chloride ion.
Chloridoligand, chloride ion or chloroligand. So this chloroligand we have to remove from dipositive complex ion. Similarly, from second complex also, let whatever number of chlorides may be there, I have to remove chloride ions and only one chloride ion I have to remove. It is a task. Which task will be easy and why? Or which task will be difficult and why? Any question you can answer. If SN1 is a mechanism, then dissociation should be there, chloride ions should remove. So for clarity purpose, I told one complex is dipositive and other complex is monopositive. From where it will be easy to remove electron. Actually, chloride ion, not electron, chloride ion, ligand. Easy to remove ligand, chloride or chlorido.
Second case.
Why?
Charge.
Explain.
Charge is less.
Right. Here only one positive charge. So very easily, readily you can remove this chloride ion. On the other hand, here two positive charges are there, relatively higher positive charge. So the easiness of removal of chloride will be less. And here Too easy to remove the chloride ion. Easy to remove the chloride ion means intermediate is forming easily. Intermediate is forming easily means reaction is going fastly. Therefore, monopositive dichloro complex undergoes fast reaction. And if it is undergoing fast reaction and is our practical observation as I mentioned here, 100 times complex 1 is slower means 100 times complex 2 is faster. If this is our practical observation means only and only possibility is there is dissociative mechanism, that is SN1 mechanism. Hence it proves that acid hydrolysis follows the path of SN1 mechanism. Is that first factor which will help us to conclude acid hydrolysis as a SN1 mechanism clear to you?
Yes, sir.
Yes, sir.
Yes. Now, second factor I am talking. Complexes were studied. Ammonia as a ligand we have used now. So, instead of ammonia, one can use ethylene diamine, NH2, that we can represent CH2, CH2, and NH2. It is our ethylene diamine ligand. When people have studied ethylene diamine and substituted ethylene diamine, here only one, that's a proton or hydrogen, is substituted by methyl group. It is a monosubstituted, or one can represent disubstituted ethylene diamine. Sorry, while writing I was wrong there. Just let me correct. Sorry, it was right. Here disubstituted. So these are substituted ethylene diamine molecules. Will anyone answer? This simple ethylene diamine will be larger or substituted ethylene diamine will be larger? Who will be larger? Substituted ethylene diamine or simple ethylene diamine?
Substituted.
Right. Substituted ethylene diamine will be larger. So they will do crowding. They will occupy more space. So this is simple complex that I am considering. It is a monodentate ammonia ligand possessing complex. Other possibility, in spite of the 4 ammonia molecule, or you can say for 2 ammonia molecule, I can consider ethylene diamine. Out of that 5, 2 ammonia molecule I am considering in terms of chelating agent or ligand ethylene diamine. Rest of the things will be simple. And third possibility I want to consider, in spite of simple ethylene diamine, I am considering substituted ethylene diamine. First case, only ammonia molecules are there, small ammonia molecules relatively I am saying. In second case, ethylene diamine is a one molecule, is somewhat a large molecule. And in third case, substituted ethylene diamines are there. And as you said, substituted ethylene diamine will occupy more space. Suppose if reaction would have been SN1, possible. Reaction would have been SN1. Then who will undergo 5 coordinate formation, 5 coordinated intermediate formation, dissociative mechanism fastly? Who will undergo? I am talking here now complex number 2 and complex number 3. What is the difference in complex number 2 and 3? Only ethylene diamine. Complex number 3, substituted ethylene diamine. What do you think? Who will undergo SN1 mechanism fastly?
Third.
Why?
More crowded, hence easily can be.
Right, absolutely. It's a understanding. See, here substituted ethylene diamine are bulgier, they are larger, more crowding is there, more space is occupied. So what will be easy? Easy will be removal of chloride ion that we want in this SN1 mechanism as a rate determining step, dissociative mechanism. So because of the easiness to remove the chloride ion, complex number 3, which encompasses or includes substituted ethylene diamine, will undergo fast reaction. Are you following what I'm saying?
Yes, sir.
Yes, that's a substituted ethylene diamine cause more space to occupy, cause liberation, removal of chloride ligand easy, dissociative mechanism is favored. Will anybody label that effect is called as? That effect is called as organic chemistry also you are studying, and even in inorganic chemistry factor supporting on thermodynamic stability I discussed that factor. That factor is called as
Steric hindrance.
Hindrance.
yes, steric factor. Steric factor, steric hindrance, yes, hindrance, opposition because of crowding. Yes, here is application of our factors affecting on thermodynamic stability. And practically also we found that substituted ethylene diamine complexes undergo fast SN1 mechanism or this acid hydrolysis mechanism, acid hydrolysis reaction. Hence, it proves that acid hydrolysis follows SN1 path. Is it clear?
Yes, sir.
Yes. Now, one more evidence that I informed to you, and that evidence is effect of increase in electron density around metal. For that, I considered two complexes, a pyridine complexes, a cobalt. I want to consider four coordination number occupation by two ethylene diamine, and instead of ammonia, I am considering one ligand. Will anybody answer which is this ligand? Py means what? Py. Ligand Py. Yes. Organic chemistry, what you consider Py means?
Pyridine.
Right, right. It is pyridine. Pyridine. So that pyridine or pyridine is basic in nature. Of course, those basic only because of that we are considering it as a ligand. So pyridine possesses nitrogen which donates the lone pair to whom? To the metal ion, as like a nitrogen from ethylene diamine, nitrogen from ammonia donates, as like chloride donates, as like oxygen from water donates. Likewise, pyridine is a lone pair donor. It is a Lewis base. It is a ligand. But pyridine of different cadres we can consider. We can consider only simple pyridine, or we can consider 3 methyl pyridine, or we can consider 4 methyl pyridine, or we can consider 4 methoxypyridine. If we see the pK values, of course pKb values, dissociation or power. Kb means what? Dissociation constant, and pKb means, or pK you can say, means power of dissociation. That power of that pK value is 8.82 for only pyridine. It was found 8.19. It was found 7.92. It was found 7.53. So substituted pyridine you can say, is with different pK values. Or if I would represent it in terms of the rate constant or the rate of the reaction, if such ligands are there, let me represent those rates also. The rate was found to be for the pyridine complex 1.1 into 10 raised to minus 5. For 3-methyl substituted pyridine complex, it was 1.3 into 10 raised to minus 5. Here 1.4 into 10 raised to minus 5. And here 1.5 into 10 raised to minus 5. The rate is increasing or decreasing? Rate of the reaction is increasing or decreasing? These values you have to compare, only these values. What do you find? Rates are increasing or decreasing? See here 1.1, 1.3, 1.4, 1.5. Everywhere 10 raised to minus 5 is there. Rates are increasing or decreasing?
Increasing.
Yes, rates are increasing. Rates are increasing because electron density around this metal ion is increasing. And that electron density is increasing because substituent A for the pyridine is different. And those are electron releasing substituents. Here methyl group, electron releasing. Yes, of course, at what position it is linked, that also matters there. Here methoxy group, more electron releasing, and because of more electron releasing, this pyridine becomes more and more basic in substituted pyridine. And since it is a more and more basic, electron density around metal ion increases, and electron density as around metal ion increases, metal ion feels happiness, metal ion becomes rich in electron. So it is ready to give electrons. It is ready to break up the chloride ion. It is ready to remove the chloride ion. It is ready to remove one of the ligand. Hence, the SN1 mechanism will be what? Easy. So rate of the reactions, rates of the reaction. That's a practical observation. So these rates of the reactions conclude that there is SN1 mechanism, and this SN1 mechanism is because there is increase in electron density around the metal ion. Yes, students, could you able to understand what I'm saying?
Sir,
Yes,
repeat.
sir.
Yeah, I repeat. See, I'm considering a complex with simple pyridine and substituted pyridines. Here pK values are given in order to know its what the power, basic strength. Here 4-methoxypyridine is powerful ligand. Powerful ligand means it is giving too many electrons. Because of that more basic approach of substituted, say methoxypyridine, cobalt gets too many electrons from substituted pyridine compared to simple pyridine. Up to here, are you understanding?
Yes, sir.
Now cobalt is with what? Too many electrons, rich in electron. Increase in electron density is there around the metal ion, around the cobalt plus 3 ion. Electron density is increased. Now that cobalt is willing, now that cobalt is ready to break up one ligand. And which is that ligand? Poor chloride ion. Why it could able to break up? Why it could able to release that? Because it is rich in electron. It is feeling warmth of electron. So now no longer it is in need of the chloride ion, means as was there before. Relatively less Igor is there. So chloride will be easily removed, readily removed. If it is readily removed, means 5 coordinate intermediate is easily forming. If 5 coordinate intermediate is forming, then certainly the reaction mechanism will be SN1. Only and only possibility is SN1. So these observations of increasing electron density around the metal ion and increasing the speed of the reaction proves that mechanism is SN1. Is it clear?
Yes, sir.
Yes, sir.
Yes. Now, the last factor that I informed to you, that is the effect of nature of leaving group. Chloride is a leaving, no? Chloride is one of the example. So leaving group, how it is, on that basis also it was found speed changes. Means if that ligand is iodide, speed was found to be the more. Ligand is bromide, relatively speed decrease. If ligand is chloride, speed is decrease further. Ligand is sulfate, likewise the variations are there. It is on what basis? It is on the basis of the nature of leaving group. How is that leaving group? How tightly bonded that leaving group? How that leaving group was a friend to the metal ion? If that was it, not a good friend, then it is easy to remove. No, just for example, only I compare these three. Among these, iodide is larger. It depends after all which metal ion is present. Bromide is relatively smaller and chloride is further smaller. Crystal field theory, nepheloxitic effect you have studied, cloud expansion. By the way, my point of interest is electrochemical series. Sorry, spectrochemical series. Spectrochemical series means arrangement of ligands in the increasing order. There you might have come across chloride is a strong ligand compared to iodide, or iodide is a weak ligand. Iodide is a weak ligand, so easy removal will be there. From whom? Suppose if I consider complex CONH35I, of course charge plus 2 as a one complex, CONH35Cl2 plus. Here removal of whom I have to do? Iodide. Here removal of whom I have to do? Chloride. What is easy? Removal of iodide is easy because it is a weak. Therefore, which react will be faster? Which reaction will be faster? A complex having iodide as a ligand will undergo fast reaction. Then whom? Then bromide ligand. Then whom? Then chloride ligand. Hence we say nature of living group decides the mechanism. When will it be possible? It will be possible only and only if there is a dissociative mechanism. We are talking about removal of electron. If associative would have been there, opposite should be the case. A case is iodide possessing ligands or that those complexes are faster in reaction. It indicates that nature of living group effects or mechanism is SN1. So students, firstly that I am discussing now what are our today's learnings. See, we're talking about the acid hydrolysis reaction. Two ways are there. One 5 coordinate intermediate formation, 7 coordinate intermediate. One is SN1 and other is what? SN2. SN1 means here removal, dissociative mechanism, and SN2 means associative mechanism, charges and separation that I discussed there. Rate of the reaction, is directly proportional to only one species it was found, and therefore we say the mechanism is what SN1 rather than what the SN2. But at the beginning people have thought that rate of the reaction might be depending on these two at the beginning, but they found to be the wrong. Practically, actually, the mechanism molecular way can be represented in these two steps. Structurally, the mechanism can be represented is a six coordinated complex, five coordinated intermediate, and this five coordinated intermediate gives the six coordinated product. On what ground we are saying is SN1, the first factor charge on the metal ion. It is found the dipositive monochloro complex is 100 times slower than the dichloro monopositive complex. The reasons that you have answered, if more charge there, difficult to remove the chloride ion. Second factor was a steric factor, crowding factor. When substitute ethylene diamine complexes were considered, it was found that the rate of the reaction is faster. It is because of steric effect. The third factor, effect of increase in electron density. For that I consider pyridine and derivatives of pyridine, methoxypyridine, which is good base than only the pyridine. Methoxypyridine can give the more electrons to the cobalt than simply the pyridine, is a good ligand or increases the electron density, and the rate of the reaction was found to be the faster for such complexes. It proves the mechanism is SN1. And at last, nature of living group also matters to decide the mechanism. It is found the ligands like iodide, which is a weak ligand compared to the chloride, and their rate of the reaction was found to be the faster, making the sense that our conclusion SN1 is the mechanism. Yes, students, are you following what I'm saying?
Yes, sir.
Yes. So I declare here today's session is over.